This tutorial illustrates how to design one periodic passage of a linear turbine cascade in ISM CFD. By the end of the tutorial, you will learn how to import point data from text files, create points, curves, and surfaces, rotate and translate the geometry, and split the geometry into multiple parts for applying different boundary conditions. The first step here is to import the coordinates of the blade as a text file. And the text file can be seen here. The three columns represent the X, Y, and Z coordinates respectively. Back to ISM, click on File, select Import Geometry, and then Point Data. We only import the points as we're going to create the curves separately. Now we can connect them using a line dividing the blade into the upper and lower part. This is because we need two different surfaces, one for the lower part and one for the upper part. So far the geometry is two-dimensional and we need it to be extruded in the Z direction. Therefore, instead of creating the geometry again with different Z coordinates, we can make a copy of it and transform it to the required position. Therefore, we use the transform geometry option here. We select the geometry we need to transform, both the curves and the points, and we enable copy here. By clicking copy, the geometry remains in place and we transform a copy of the selected geometry. We select translate and the offset will be on the Z direction, in the positive direction. Now the geometry is three-dimensional. The leading edge points can be connected using a line, and then these lines later will define the two surfaces. For the creation of the upstream region, instead of creating new points, we select them and transform them on the negative direction of the x-axis. Again, by making a copy of them. You can see the newly created points here. So this is one side of the upstream region, which needs to be rotated as it has an inlet angle which is 22 degrees. The center of rotation will be the selected point, which is this one here. We click apply and then the geometry is rotated. We can do the same for the downstream region. We select the points, copy them, and then specify the offset. We follow the same process as before. Create lines and then rotate both the lines and the points around a specified point, which in this case would be the trailing edge point. Select the rotation point. And now we create surfaces by specifying the boundaries, which are curves. Now they are in wireframe mode, but if you want to have a better visibility, you can turn them to solid. This is the upper surface of the airfoil of the blade. Now we only created one side of the periodic passage, and we need to copy that and specify the offset to make the other side. And now we have a complete passage. Therefore, Instead of creating both sides, you can create only one side, specify the distance between them, and then transform it. The curves here are created in order to define the boundaries of the surfaces. After that, we're going to create some surfaces. We forgot to create one line here, therefore we can go back to curves and create it. Once you have selected the curves, you press middle click to create the surface. Now the volume is fully enclosed. As you can see, two of the surfaces here are not needed, and this is the lower surface here and the upper surface here. Therefore we can delete them using the delete surface option. And the same for the curves. We can split the geometry into different parts in order to specify different boundary conditions. Once we create a new part, the color of the entity will change. At the moment, the whole geometry has the same color. This is the inlet, which is now blue. We do the same for the rest of the parts by, of course, specifying different names. Next is the upper surface of the airfoil, and the boundary condition here will be a wall. And we select the surface as well. The surface is the most important. if two surfaces have the same boundary condition, you can include them in the same part. If not, you have to divide them into different parts. When you specify boundary conditions later, you will see the part name. And for each part name, you define the type of boundary condition. Even if you have already created the part and you have forgotten to include something, for example one surface, you can right click on the part name and then you select add to part and you select the entity you want to add. The geometry is now split into different parts. Upstream, the passage of the blades, and the downstream region. Now the last thing to do is to create a body, which simply means that you create a volume for which you can specify a boundary condition later. For example, this volume can be either fluid or solid or one specific zone of the fluid. And now the point is within the enclosed volume.